The next type of division we're going to be looking at is synthetic division. Now, synthetic division, unlike long division, you can only use it to divide polynomials where the function on the bottom, so the divisor or divisor, is a linear function, and the leading coefficient is a 1. Okay, so degree of 1 and leading coefficient must be a 1. Okay, if it's not that, then you can't use synthetic division. So if I look here, my degree is a 1. Then out here at the front, my leading coefficient is also a 1. So therefore I can do this one. Now, it's gonna look a little goofy, but it's actually easier, in my opinion, than long division. What you do is figure out what makes your bottom equal 0. So x minus 6 equals 0. So you're going to set your bottom equal to 0 and solve. What that is goes up into this box up here in the top left that you make. You then write your lead or your coefficients all the way down to your constant. So here I don't see anything, so it's understood 1. So this is a degree of 2. My degree of 1 term is a -4. My degree of 0, or to my constant, is -12. If you do not have, or say if this -4 was missing, just like with long division, you would have to write your term so it goes in descending order, decreasing 1 degree value at a time until you get to your constant. Then what you do is you bring your first number down. You then multiply that number by what's in the box. So 1 times 6 is 6, and you add. So -4 plus 6 is 2. You then multiply what's under the line by what's in the box, and you add. Now the thing at the very end is what your remainder is. And you then write this as a polynomial. So remainder, constant. So positive. And then 1x. If this would have been like 3, 7, -5, well, so it would go remainder, constant, degree of 1, degree of 2, degree of 3, degree of 4. So it would have been plus 3x squared, 7x cubed, minus 5x to the 4th. But we'll get into that right here in a second. So we're going to try to do the second one. Again, degree here is a 1. This isn't a linear term, or excuse me, this isn't a 1. So I can't use synthetic division here. Okay. Again, like I said, just doing a couple of examples. So you take the opposite of what you have here. So negative 3 is really going to be a positive 3. And then look at your degree values, 3, 2, 1, constant, so it doesn't skip any. Then you just choose your leading coefficient. So 1, 6, negative 21, negative 18. Bring this down. I always put my box here because I know that this is where my remainder is. Again, bring down your first number, multiply, add, multiply, add, multiply, add. Write this as a polynomial. So 54 divided by r minus 3 plus, then here's my constant. 15 is positive, or 24 is positive, it'd be 15x. X squared. And that's my answer. Okay. Again, check your degree, check your leading coefficient. It's possible to do. 3, 2, 1, 0. So get your problem set up. So 5, 1, negative 11, 22, 40. Bring it down, multiply, add, multiply, add, multiply, add. Write as a polynomial, remainder, constant, degree of 1, degree of 2. Let me find one where it's a little bit different. All right, so number 9 is a good one. All right, so degree of 1, coefficient, so we're good. I set up my problem. Negative 1. Now if I look, 2, 1, as soon as I get here, a flag goes up, so I know I'm going to need to rewrite this. So I have a 3, a 2, and then a 1, last but not least a 2. Then I can come and take my coefficient for each term. Again, bring your first one down. Once you bring it down, you start multiplying and adding. Remainder, constant, degree of 1, degree of 2. If this is not a 0, you're going to divide by what you originally divided by, just like we did in long division. Now what we can do, right, because this technically is still division, is we can come over here and double check our work. Don't be concerned about what the graph looks like. Again, what you're concerned about is if your graphs overlap. They do, so therefore I know I have the right answer.